Okay, so we're looking at the limiting sum of an infinite geometric series. So that is our learning intention, to gain the knowledge on how to calculate the limiting sum of an infinite geometric series. We'll be successful if we understand what the term diverge means, if we understand what converge means, and if we're able to use this formula, S equals A over 1 minus R when R is less than 1, and this is on our formula sheet. This one. Okay. So, when we have some series, some geometric series, right, the sum becomes very large as n increases. So here I have a series where I'm doubling the number. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. If I keep adding those numbers, so 2 plus 4 plus 8, right, 14 plus, and I'm going to add the 16, and I'm going to add 32. The number gets bigger and bigger and bigger unto infinity. And so we can't really add all these numbers. And so what we say is that this series diverges. The sum is infinite. But in other series, the sum approaches a constant value. So here, what's happening is I'm timesing it by a half. So 8 divided by 2, or times by a half, is 4. Times that by a half is 2. Times that by a half is 1. And if we look at it, so 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. Now if I'm going to add a half to that, it's 15.5. Then I'm going to add a quarter, it's 15.75. Then I'm going to add 1/8, right? The increase is so small that eventually I will come to a constant. Like if I keep adding, I'm approaching a constant, which means the series is converging. It's going to converge to a limiting sum, right, to a number. So these have a limiting sum. So any series that has a ratio, a common ratio of a fraction, will have a limiting sum. So if the absolute R is less than 1, or R is a fraction, then it has a limiting sum, and we can use this formula. The sum is the first term minus 1 minus the ratio. So if I was to do this for that, right? So the first term in this situation was 8, and the ratio was a half. So 8 over 1 minus 0.5, we get 16. So as you can see, the numbers were converging closer and closer to the number 16, to the sum of 16. So we want to find the limiting sum of these following geometric series. So I need to know what my A is. In this case, it's going to be 40. I need to know what my common ratio is, which I find by taking the term and dividing it by the previous term. So that's going to be a half. Okay. So I notice that the absolute R is less than 1, so I can use this formula. So I've got 40 over 1 minus a half. Which gives me a limiting sum of 80. But as we keep adding the numbers, it's getting closer and closer to the sum of 80. Okay. Here I've got A is 6, R is 3 on 6, which is equal to a half again. Okay, and I need to state that R is less than, the absolute R is less than 1, so it's a fraction. I can use this formula. So A is 6, now R is a half. So 6 divided by 1 minus a half is 12. Okay, so here we've got A equals negative 12. My R is 2 over negative 12, which is equal to negative 1/6. So as R is less than 1, I can still use this formula. So So negative 12 divided by 1 minus negative 1/6. Negative 12, 1 minus negative 1/6 gives me negative 72/7, and as a mixed number you get negative 10 2/7. Okay. We want to find the difference between the limiting sum and the sum of the 6 terms of this geometric series. So I know that A is 56 and R is negative 28 over 56. That looks like negative a half. Yep. So as the absolute of R is less than 1, the limiting sum is that. So A is 56, 1 minus negative a half. So 56 over 1 minus negative 0.5. And maybe do it 112 over 3. Okay. Now the sum of the 6 terms. So Sn, so this is less than, alright, so I'm going to use this formula, A1 minus Rn, 1 minus R, okay, so A is 56, R is negative a half, N is 6, 1 minus negative a half. So if I plug that into my calculator, I get 56, 1 minus negative a half to the power of 6, 1 minus negative a half, or 1 plus a half, which gives me 147 over 4. Now the question says find the difference between, so the difference of the limiting sum and the sum of 6 terms. Okay. So 112 over 3 minus 147 over 4 gives me 7 over 12. Okay, which is equal to 0.583 repeater. Okay. Here's another example. A geometric series has a limiting sum 6, a common ratio of a third, and we want to find the first term. So we know that the limiting sum is using this formula. It says the sum is 6, so it converges to the number 6. We don't know what A is, that's what we want to find, but we know that it has a common ratio of a third. Okay, so that's 1 minus a third equals 2/3, so 6 times 2/3 is 4. So A is equal to 4. Okay. The limiting sum of a geometric series is negative 3/10, and its first term is negative a half. So we want to find the common ratio. So we know that, still using this formula, this limiting sum is negative 3 on 10. the first term is negative a half. Okay. So if I was to multiply, I'll do it step by step, multiply that across, I would get that. Divide by that. So negative 0.5 divided by negative 0.3, I get 1 minus r is equal to 5 on 3. Swapping these two around, I get 1 minus 5 on 3, which equals r. So r is negative 2/3. Just using the formula and using algebra to find the unknown. Alright, last example. Yep. A geometric series has a second term of 2/3 and a fourth term of 8/27. We want to find a and r and its limiting sum. Okay. So we know that we can find a term of a geometric series by the formula a r n minus 1. Okay. We're given the second term, so we know that we know that 2/3 is equal to a, which we need to find. We need to find what r is, but n in this situation was 2, so 2 minus 1 is 1. Beautiful. Okay. Now the fourth term is a over 27. So we don't know what the first term is. We don't know what r is, but in this sense that's going to be 4 minus 1, so it's 3. Okay. Now from this formula, really r is equal to 2 over 3a. And I'm going to just sub 1 into 2. So a over 27 is equal to a. R is 2 over 3a cubed. Okay, so that is 2 cubed is 8. 3 cubed is 27a cubed. Okay, cancelling out that a, leaving me 2. Yeah, so we have cross multiplying okay, so a squared equals 8 over 27 divided by 8 over 27, which is 1. So the square root of 1 is plus or minus 1. Okay, so a is plus or minus 1. Okay, now we want to find its limiting sum. Okay, so we have two solutions, so we need to try both solutions. So when a equals 1 and I need to find what r is, so I'm going to sub so maybe I do it on this side. When a equals 1, r is going to be 2 over 3. Okay, and using then finding the limiting sum, we get a 1 minus r, so we get 1 minus 2/3. So 1 divided by 1 minus 2/3 gives us a limiting sum of 3. But when a equals negative 1, r would be equal to negative 2/3. So using the formula, we've got negative 1 minus negative 2/3. So negative 1 minus negative 2/3, we get negative 3/5. So in this situation, there are two solutions, right? So we have, when a equals 1, we get it diverging to positive 3, and when a equals negative 1, we get it diverging to negative 3/5, or 0.6. Okay, good luck.